Verify that the indicated function is a solution of the given differential equation on the interval negative infinity to positive infinity. The differential equation that we are investigating here is y double prime minus 6y prime plus 13y equals 0. And the function that we would like to prove is a solution for this given differential equation is y equals e to the 3x cosine 2x. You should notice that within the differential equation, we have the second derivative and we have the first derivative. Therefore, that should signal that we are going to need to take the derivative of this equation 2 separate times. Starting with the first derivative, you should remember that when you are multiplying two functions by each other, and you want to take the derivative, you're going to need to use the product rule. With the product rule, I am going to hold or not change e to the 3x, and I am going to multiply that by the derivative of cosine 2x. The derivative of cosine is negative sine. We're going to have to use the chain rule because we have 2x inside of the function cosine. So that gives me negative 2 sine 2x, and I'm going to add that to the other part of the product rule, which I hold cosine 2x, I don't change it, and I take the derivative of e to the 3x, which gives me 3e to the 3x. And again, if you aren't remembering how to work through all of these assumed skills, you really want to brush up on taking the chain rule, taking the derivative of some of the more complex equations. In addition to that, you want to brush up on integration. You will be going back and forth within this course, and you really want to make sure that you understand both taking the derivative and taking the integral. So continuing or simplifying this equation, we now have y prime is negative 2 e to the 3x sine 2x plus 3 e to the 3x cosine 2x. Now remember, we need to take the second derivative. So we're going to take the derivative of the first derivative, which will give us the second derivative. Again, we have the product of two functions, so I'm going to apply the product rule to this term, but I'm also going to have to apply the product rule to this term. So that means we're going to apply the product rule 2 separate times. I am not going to change negative 2e to the 3x, but I'm now going to take the derivative of sine 2x. Again, I'm using the chain rule. The derivative of sine is positive cosine. So I have 2 cosine 2x plus, and remember again, we're still with the first term. We're going to have to take the product rule or apply the product rule 2 separate times. And we're still within the first of our attempts. So this time I'm going to hold or not change sine 2x. And I'm going to take the derivative of negative 2e to the 3x, which gives me negative 6e to the 3x. And remember again, when you are taking the product rule, you have to keep up with which one you're not changing versus the one that you are taking the derivative of, mainly because when you're dealing with the quotient rule, order matters. Here, it doesn't matter, but you want to have a systematic way of working through it. So if you are presented with a quotient rule, you make sure that you have the correct terms flowing in the correct order, because there is a subtraction sign and that can change the sign of your final answer. Whereas with the product rule, you only have an addition symbol, and under, I'm sure you all remember the properties. All of these things are coming together within this course, but under the algebraic properties, you can change the order, and changing the order would be the commutative property. So again, I have y double prime, and let's finish off the second part. I want it to simplify, but it'll be easier if we work it all the way through, just so that you can see where all the parts are. So we're going to hold 3e to the 3x. When I say hold, I mean we're not going to change it. And we're going to take the derivative of cosine 2x. Derivative of cosine, again, is negative sine. Chain rule, negative 2 sine 2x. And we're going to add holding cosine 2x. And then take the derivative of 3e to the 3x, which is 9e to the 3x. So now we're going to simplify all of this wonderful math goodness. And that gives us negative 4e to the 3x cosine 2x minus 6 sine 2x. And again, we have another minus 6e to the 3x sine 2x. And here I actually left off the 3x. So I'm going to go back and make sure we have that. So when you simplify, you don't want to make mistakes because you didn't write things down correctly. And the reason I'm not re-recording is I want to show you that mistakes are human nature. And then we're going to add 9e to the 3x cosine 2x. Now we're going to simplify all of this wonderful math goodness. That leaves me with a negative 4 and a positive 9, 5e to the 3x cosine 2x. And then we're going to combine like terms here to get negative 12e to the 3x sine 2x. After all of our simplifications, we have y prime equals negative 2e to the 3x sine 2x plus 3e to the 3x cosine 2x. And we have y double prime, or the second derivative of y, as y double prime equals 5e to the 3x cosine 2x minus 12e to the 3x sine 2x. As we did with our previous example, we are now going to go back to our original equation and substitute all of the values in. So this is going to take a lot of concentration. Please make sure that you practice this problem, and I really recommend that you have a big sheet of paper because we have a lot of substitutions and it's easy to get things lost. So we're going to start with substituting in the value for y double prime, which we said is 5e to the 3x cosine 2x minus 12e to the 3x sine 2x. And then we're subtracting 6 times y prime, which we calculated to be negative 2e to the 3x sine 2x plus 3e to the 3x cosine 2x. And then I'm adding 13y. So 13y is simply e to the 3x cosine 2x. All right, so let's work through simplifying this. This doesn't change. 5e to the 3x cosine 2x minus 12e to the 3x sine 2x. Now here I have negative 6 times a negative 2, which gives me positive 12e to the 3x sine 2x. And I'm also going to distribute that same negative 6 to this term, giving me negative 18e to the 3x cosine 2x plus 13e to the 3x cosine 2x. And we're attempting to prove that that equals 0. So let's now go through and collect like terms. I'm going to switch colors. I know that some people can kind of see things on their own, but every now and then you need a little bit of an aid. So I'm going to provide that right now. And I want to get a good contrasting color. I'm going to go back to our bright orange. Now I want to collect all the like terms. So I have a cosine 2x here. So what I'm going to do is everything with the cosine 2x, I am going to underline. So I have cosine 2x here, and then I have a cosine 2x here as well. And every part of the term, of course, you know from algebra, all parts of the term need to be the same in order for you to combine the like terms. The only thing that, of course, can be different is the coefficient. And then here, I'm going to give squigglies to everything that is a e to the 3x sine 2x term. So you should see immediately the negative 12 and the positive 12 cancel each other out, leaving us with the additive identity. I'm using terms that you should remember, which is 0. Then I have a positive 5 and a negative 18. I'll subtract to get a negative 13. Negative 13, positive 13. Hey, all of these terms together work to give us 0. Therefore, 0 equals 0, and we have verified that the indicated function is indeed a solution for our differential equation.